Right. So we're here today to talk about, we also changed our title slightly to describe a little bit more what we're actually doing here. So we're here to talk about external model connectivity for digital twins. So today we'll give you a little background on this project, the motivation for why we built this. We're actually going to show the demo right up front in case you're not familiar with SAP, which is the technology we're working with in combination with AnyLogic. And if you don't have any background in manufacturing, it'll just feel a little more real. And then we're going to talk about what we did to make this project successful, and that includes both the technical challenges and also the time that we spent with the stakeholders and the end users to make sure that the project would feel real. So you've already heard our intros, so I won't spend any more time on that. We do just want to recognize Lyle and Cindy, who gave us great guidance on this project, and our senior members of our team who are not here today. So this project was a combination of AnyLogic and SAP Digital Manufacturing. So SAP Digital Manufacturing is a newish module within SAP, if you're familiar with that ERP. And what it's for is connecting with physical production environments, so industrial machinery, factory floors, things like that. And it allows you to have real-time connectivity with those assets and that environment in a way that you can't without being there. So it's great for kind of transparency, collecting data, analytics, and being able to remotely monitor that environment. And for us, the objective was to see if we could build a simulation model that would mimic a physical production environment. So one of the issues with testing out something like this is if you don't have a physical environment to connect it with, it can be really hard to learn and make any progress in getting ready to use it. So that was our objective, was to kind of integrate the two, find some new capabilities for our team within AnyLogic, and solve these very interesting technical challenges that came up associated with that external connectivity. Background on the motivation for this project. So at PwC, it's a very big company. We do a lot of different things, not just simulation modeling. And we have consulting teams who work with clients every day to implement the SAP modules of various types. So they were, of course, very excited about this new solution. They wanted to get better familiarity with it. Like I said, it was hard for them to really play with it, to get deep familiarity with the functionality and the capabilities, because they didn't have an environment to hook it up to. So this would be a really great solution for them, not only for that learning process, but also to give effective visual demonstrations to clients. So there's not a lot of visualization capability built into the SAP module yet, and that was another great benefit that they were going to get out of this project. On our side, in the modeling team, we were very excited to do this project because it was going to give us an opportunity to work with things like APIs, external connectivity with the model, and kind of expand the solutions and capabilities that we have around digital twins, which is something that our team is very interested in. So we're going to show the demo. This is just a short video. You'll see kind of the integration of the two systems. So at times, you'll be seeing our AnyLogic model, and that'll look familiar. The other views that you'll be seeing in the video are actually from the SAP Digital Manufacturing module. So hopefully that gave you a feel for what we were actually talking about here in terms of the two systems working together, sending data back and forth. So this was a really successful project for us, and I just want to talk a little bit about what we did to make it work so well. And there's two components to that. One was obviously the technical piece, which Hannah's going to get into in depth. But the other one was that we spent a lot of time trying to really make this feel real and make it seem relevant and resonant for both the consulting teams that we were working with and their eventual clients. So there's a few ways that we did that. We had a bunch of goals with this project, but among them, building that baseline understanding and capabilities for the consulting team, so allowing them to become really familiar with the module, with the APIs inside it, with the different capabilities it has, that was very important. We wanted to pick a very relevant environment for the digital twin to replicate, so something that anyone from within their groups of clients would be able to recognize, to feel familiar with, and understand without needing to spend a lot of time explaining what is happening in this digital twin. And we needed to do all of this pretty quickly. So they had been invited to be part of the SAP booth at the Hanover Fair, which is a really big industry conference that happens in Germany every year. This consulting team that we were working with were based in Germany. So we wanted to get this all put together quite rapidly and have it be fully functional for that demo booth. So to do this, we spun up an instance of the SAP module just for ourselves to do the testing and exploration, and that involved a lot of collaboration back and forth with the German consulting team. So they were also hands-on with the module, learning how to design the workflows, learning how to integrate it, and that was really valuable for them. We also spent a lot of time talking to them about the model itself, the digital twin that we were building, the relevant use cases that we wanted to module. So it was very important to pick things that, again, people would recognize and that would be relevant. And us, as simulation modelers, although we have some baseline familiarity with manufacturing environments, with logistics, we're not experts and we're not in the culture. So getting that feedback from them was really critical to make sure that this was something that they could really use with their clients. Last piece, to be honest, I don't think that we could have done this with any solution other than AnyLogic. First of all, we had a great demo model to start from. We didn't have to start from scratch with that. We used the solar panel manufacturing floor. The process modeling blocks, all of that built-in functionality that you're all familiar with, really sped up the development process for us, and it let us focus on the much more complex, I would say almost engineering challenges that we had to solve. And the ability to write custom Java code was critical to being able to do this project. We had to do the API integration. There was some multi-threading. It got very complicated. So a lot of custom code in this project. And that's what enabled us to get it over the finish line. So I'm going to turn it over to Hannah Shapiro. She was the lead modeler for this project, so she's going to talk to you a little bit more about the details of the technical challenges as well as the use cases that we chose.
Thanks, Hannah. So as Hannah mentioned, we had to select a couple different use cases from the digital manufacturing module within SAP. And this SAP module was very new, and there were tons of different APIs to choose from, lots of different functionality. But we needed to pick a couple different use cases that could resonate both at the Hanover Fair and to our clients and could be interesting to look at from a potential client side of looking at how something's happening on the AnyLogic side as well as its counterpart in SAP. So we needed something that would be represented in both. We ultimately ended up picking 3 different APIs. From the modeling side, we wanted more interesting APIs, like what if we made something really cool, like Zeus throws down a lightning bolt and causes a machine to blow up? And that's what triggers the API call. From our counterparts on the SAP side, they said safety is very important in manufacturing, and we don't want to trigger anybody. So we kept it a little bit more simple with just that caution sign that you saw in the model. But we ultimately picked a quality check, so scrap API. Whenever a solar panel enters a station, every so often there's a check to see if it's functioning appropriately. If it's not, it's removed from the station, triggering a call in SAP. We also picked this machine down, where unfortunately no lightning bolts were used, but we do have a caution sign triggering a maintenance call. And then we also picked a start confirm station. So this represents the transparency as well that you can see. So at any point, a factory manager, for example, can look up and see exactly what station each solar panel is in on the manufacturing floor. And then moving on, so this model was demoed at a fair. We wanted it to be nice and eye-catchy and demonstrate a modern factory. which AnyLogic gave us a great start with this blue and green, but in order to sell PwC and sell this, we wanted to give it a little bit of a facelift. At PwC, we have a few different 3D artists, so we were able to use AnyLogic's ability to upload custom 3D models and change the colors to make it look a little bit more modern, more silver with the red. PwC's colors are red, orange, pink. So we wanted this to be eye-catching and to represent the future of your manufacturing floor. And in addition, Hannah mentioned this, that we did this model specifically for the Hanover Fair, but we also wanted it to be a model that could tell the story in any amount of time. So we needed this to be a model that could run for 8 hours at a conference booth, but also be able to run for 5 minutes, or to be able to tell the story in all of these 3 different use cases to anybody who passes by the booth. So we needed a team member to be able to demo the model shortly, as well as different technical challenges of, I don't know if any of you have run a model for 8 hours straight, but making sure that there would be no bugs and no issues for that long period of time presented some challenges itself, as well as having to demo this showing both the AnyLogic side and the SAP side. You need 2 screens. So we created that video, that's how we shared it today. But at the model itself, at the fair itself, they had 2 desktops where they were able to show both SAP and AnyLogic and be able to point to what was happening in each place. So with that, we have 4 specific technical learnings that we want to share. There are a few challenges that we came across as we were building this model and working both with the SAP team and as a modeling team. There are a few different interesting questions that this posed that we had to overcome. The first being specifically with SAP Digital Manufacturing Cloud, this being a new module, there wasn't a ton of documentation around the different error codes that could pop up, and also our team was pretty inexperienced due to never having implemented this type of project as to how the different APIs worked. So we were getting various error codes throughout the model run. For example, like a solar panel is put onto the manufacturing belt, brand new solar panel. It is asking SAP, what's the next order? SAP may return, we're out of orders. We have nothing left. In order for our model not to crash when this happened, we had to build in some custom checks to make sure that when we're asking for an order number, there is an order in queue. And this also added more complexity on the SAP side of queuing up orders dynamically when, in the event that we ran out, we could address that problem without having the model error out. The next issue comes with timing. So in manufacturing, things take a lot longer than they do in a simulation model, which is one of the benefits of using a simulation model for optimization, et cetera. But an API call on a manufacturing floor that takes 3 seconds, not a big deal, when that station may take 30 minutes, an hour, 2 hours to complete. 3 seconds on either side of that is not going to delay your production very much. But in a simulation model, when each station is taking 1 second, the timing for that API call to then return causes a physical lag in the simulation model. Hannah mentioned this before, but in order to address this, we had to implement this methodology of multi-threading so that API calls could run simultaneously and not present a significant visual lag in the simulation. So that's how we're able to run many solar panels in the matter of 5 minutes instead of having to wait for 30 minutes for a solar panel to finish each station. With this timing issue presented a new timing issue with SAP. So with the API calls running in this multi-threading technique, a solar panel entering one station can make that API call, hey, I've started the glass cleaning station, to SAP. In AnyLogic, that station might only take less than 30 seconds to complete, maybe 1 second, because we're running at 5-10 times speed. But in SAP, it is still registering that that solar panel has entered that station when a new API call from AnyLogic is saying, hey, I'm already done with glass cleaning. In SAP, they have to make sure that you have completed the start call and end call before that solar panel can be released so that each station is timed appropriately. Because if the solar panel was supposed to still be in glass cleaning but is telling SAP that it has now moved on to the next station, that produces errors, and that ultimately provides no insight to whoever is managing that factory. So in order to address this issue, we needed to make sure that the AnyLogic model validated the send portion of the API, as well as the confirmed production of the API within each station. So each processing time for the station in AnyLogic included not only the processing time of how long that station was supposed to take, but both API calls on either end to make sure the solar panel was not able to move on to the next station until that entire process was complete. And then finally, with any enterprise software, you have all sorts of corporate security protocols and making sure that you can hit external APIs from within a software behind your firewalls. So we needed to make sure that this model could interface with SAP on many different laptops, because Hannah and myself are from PwC US, which has slightly different security protocols as PwC Germany, who is ultimately demoing this product, as well as SAP factory authentication. So we used O-authorization, which generates a bearer token so that we are making sure that we are hitting our SAP instance. And with this, going back to that initial of the solar panel model needing to run for 8 hours in one day, the bearer token needs to be regenerated every hour of real world time. So we had to build that into the model to make sure that regardless of model time, real world time, every hour a new bearer token is generated, so we don't have any authentication issues when it comes to running our model. And with all of those technical learnings, I'm going to pass it back to Hannah to talk about the vision for the future and how we plan on using all of these really important insights in this model for what's next.
So as I said, this was a really great project for us. We're super happy with how it came out. We learned a ton, and we have a lot of thoughts on how we can build on this success, both within our team, so within the simulation modeling team, and also for the consulting teams. So one thing that will be really useful for them is to try using this as kind of a pre-implementation sandbox. So when they go out to do a project with a client who wants to potentially implement this module in their production environment, they have the ability to do all of this experimentation and planning and education with the client before actually having to invest in hooking it up to the physical production environment. So a lot of savings there, a lot of things that we learned through this project, like the timing between the different stations, a lot of that can be worked out in advance using this type of approach. It can also be used, for specific kind of optimization projects, for resource planning. There's just huge benefits to being able to do this without physically having to do it. So all kinds of things you might do if you're thinking about a new facility, or if you're potentially changing the layout of a current facility, investing in some new assets, whatever it might be. Just that ability to kind of experiment in advance, spot things like bottlenecks or issues that might arise with a new layout, kind of avoid problems before they come up, and plan for maximum efficiency, I think is going to be a lot of value for the SAP consulting team and for their clients. And then for us, on our side, this was just a very exciting project for us to get to build a twin and have real-time data coming in and out of it. And all of the technical challenges that Hannah just went through, we learned a ton in that area. And I think we're really excited to look for areas other than manufacturing to apply those learnings, look for other places where we can build these kinds of impactful digital twins that have real-time data flowing in and out. So that's all we have for today, and we'd be happy to take any questions.
Dominic Finazzo. I was wondering if you had any issues sort of convincing the manufacturing space about like simulation and digital twinning. Like, did you find any particular struggles in doing that when you were at that conference?
So I don't think that they had. I don't think that that really came up in this context, because at the conference they were really using it as a visual demonstration tool. So while perhaps they, TBD if they run into those kinds of questions when they're using it as a sandbox or as kind of a design tool for a facility. But from this perspective, I think it was very positively received, because this module, as you could tell probably in the video, it's kind of hard to visualize and understand what it's doing, and to kind of integrate that with your mental model of your factory floor. So I think that was extremely well received. They got really positive feedback at the conference for that. Certainly, like, sometimes there's resistance to the idea of building models, or spending a lot of time building a model. Another thing I would say about that is these projects, the implementation projects, are big and very complex. So the cost of using something like this is still going to be small relative to what they might be thinking about doing and relative to the investment that they might be making in the physical environment. Better to spend a small amount of money up front comparatively and get those learnings. And so that's, I think, hopefully how they will kind of pitch it with clients and talk about it.
Hey there. Very interesting stuff. Hi. Where did you implement the multi-threading?
Where did we implement the multi-threading?
Oh, great question. In every API call, we're making this within a custom Java class. So as I mentioned, there were 3 different APIs, and each of those were their own class. And each class we're running with that multi-threading technique.
Thank you.
Thank you for the presentation, very interesting. I wanted to ask you something regarding the digital twin. Like, based on what I understand and then what I see that you guys did, you are connecting live to the real data of the facility, right? And you are assessing the performance, maybe changing some parameters where you can like experiment with it, right? But I was wondering if you guys thought or you have like implemented something like giving feedback back to the system, like maybe like making some decisions based on it. If you maybe analyze like disruptions whenever something goes wrong in the facility, does your model allows to like test like different solutions or something like that?
Yeah. So if I understand the question correctly, you're asking about if, say, there's a disruptive event, if we can feed that information back into the model.
Yeah.
Yes. Okay. So this model, it was built to demonstrate the digital manufacturing abilities. But the way that the SAP module works is that it has its own dashboarding mechanisms. So in addition to like order planning, I believe it showed up in the video when there was a machine down. It showed like one resource down, essentially. How we see this being used is that can then be taken to maybe manufacturing engineers or plant organizers, and then they can make decisions based on how they're seeing it, test it with it by using the model. So if they think, oh, maybe we should have more technicians, or maybe we need 2 more of this one station to make it run smoother, then they can change that in the model and then see how that reacts in SAP before doing it on their floor. Absolutely. And I think the main benefit of this specific model and use case would be to be able to configure your SAP module portion of it appropriately so that it can handle those changes on the factory floor. Because a big part of these SAP implementation projects, and specifically digital manufacturing, is that the configuration on the SAP side is not as user-friendly per se as looking at an AnyLogic model. So being able to make those changes in your model and then set up your SAP module appropriately to reflect those changes before taking it to the floor, I think is the main benefit.
Thank you. So just like a follow-up question, have you in any of the projects you guys work on like ever connected like the way back into the SAP? Like, are you just changing tasks in the SAP based on the results of your simulation? Or like, is there a feedback loop information-wise? Or is it just like you collect the live data, make decisions offline, like planning, and then like just implementing it independently? Like, is there any like live information going back from the model to the system, to SAP?
Yeah, so this, although we say digital twin, which I think sometimes people think of, you might be thinking of the type of digital twin that has kind of forward-looking predictive analytics in it, where we're looking, like you asked about a disruption, how would the disruption like flow forward? What would be the follow-on impact of it? This more so was meant to get around the issue of having no physical production environment to connect with and allowing experimentation with the SAP module. So the simulation model itself is meant to be very simple and just reflect basically a normally functioning manufacturing floor, and then allow the team to be experimenting with SAP. In future, I could see, maybe you have some version of a twin that's reflecting your actual floor, but is more forward-looking, so that you could look at something like disruptions and what might happen or how you might plan to respond to them. I'm not sure that's something that's really contemplated in the SAP module, but could be something that you might develop. But this was much more kind of self-contained thing to let us represent or mimic a factory floor that we can then connect to.
Thank you very much.
Hi, great presentation, and it's amazing to see people so excited. I'm here right in the front.
Hi.
So excited to talk about digital twins and SAP. My question is very similar. My name is Alan Barnard from Golden Research Labs, and we are working with PwC at the moment. I was just thinking about whether you've had those discussions. So for example, that disruption that's taking place, it's not always obvious whether the impact of that disruption is enough to have to reschedule, come up with a new plan, for example. So I can see how that could potentially work. The disruption happens, it's fed into the AnyLogic module. You press the play button to see if it's going to have a big impact, yes or no. And if it does, and you have to reschedule, use the scheduling logic inside of AnyLogic to reschedule the plan and output that plan back into SAP. Is it a discussion that's already taking place, or is it one of the future next steps that you might be getting involved in?
I think that's something we imagined as like a future work that we could do. So that would probably be another project we would do in collaboration with the SAP consulting team, is to build, now we've done this kind of proved out, the connectivity was a big, I would say that was one of the primary goals of this, was just to prove that the connectivity was possible and that we could use the simulation model in this way. But definitely, I mean, obviously looking to make the simulation model itself more sophisticated is something we would be interested in doing, for sure.
And just a follow-up question for the audience also, total time for the project from when you started until the deliverable was done, how long did that take approximately?
It took about 2 to 4 months, and I would say that a vast majority of that time was not spent in AnyLogic. It was spent understanding the SAP module.
Yeah.
So, and again, with the beautification aspect of the model. So making the video to demo it, making sure that everything looked PwC branded, and making sure it was easily digestible and telling the story. So there was a lot around the business use case, and then I would say about 40 to 50% of the time spent on that like multi-threading and making sure we understood how AnyLogic was working with SAP.
Thank you.
Thank you.